Hello everyone. In this video we are going to work out these AP questions for chapter 1 and 2 in case you need to hear any explanations on why something's wrong or right. So the first one is looking at two box plots and you're trying to decide which of the following statements must be true. And so the first one says set A contains more data than set B. Okay, so that's just talking about your sample size. All we know from a box plot is the 5-number summary, right? We know what the minimum value is, the Q1, the median, the Q3, and the maximum. We have no idea how much data, how many observations was in our data set. So we have no way of knowing that just by looking at a box plot. This sample size could have been 50 or it could have been 5. So which of the following must be true? That one we don't know. The box of set A contains more data than the box of set B. So that one's very similar. It's saying this box, between your Q1 and Q3, there's more data than this one. And again, you have no way of knowing the amount of data. We just know the spread of the data. So that one can't be true. So hopefully number 3 works. It says the data in set A has a larger range than set B, which makes sense because range is max minus min, and if you look here, that is going to be larger than that. So number 3 is the only one we know. The next one says the heights of adult women are approximately normal with a mean of 65 and a standard deviation of 2. If Rachel's at the 99th percentile in height for adult woman, then her height in inches is closest to. So you don't have to write this on a multiple choice. Obviously, you can write as little as much as you want. But anytime it says normal in here, I'm going to try to use that notation. So we know it's normal with a mean of 65 and a standard deviation of 2. So if we draw that, 65 is in the middle, and then you go to away, which you can show that if you want, or if you wrote this on a free response, you wouldn't need to. And we know Rachel's at the 99th percentile, so that means she is far over to the largest set, and this area beneath her, there's 99% beneath her. So that area needs to equal 0.99. And we want to know what is her value right there. So how do we do that? If they give you area and you're looking for the observation, that's when you do inverse normal. And then you type in the area, when you do inverse normal, you always type in the area beneath, which is 0.99, the mean, which is 65, and the standard deviation, which is 2. And if you type that in, which I can show you how to do it in the calculator too, in case you forgot, you would go to Menu, Statistics, Distributions, which is 5, inverse normal, which is 3, type it in, and you get, that doesn't seem right. Oh yeah, that's a value, or so I was thinking that was area. Never mind. So this value right here would be 69.65, and it just says which one's closest, so we would go with 70. Okay, next one says which of the following is the best estimate for the standard deviation of the distribution shown. So if you just look at this, most of you would say, okay, we know the mean's in the middle, the standard deviation is how much you go over, and about 3 standard deviations to get you to like the edge. So this is your standard deviation, that distance that you go over on each side, which would be 10. And that's correct in this problem. Now theoretically, I haven't really talked about this a lot in class, but so if you look at that point right there on the curve, that's considered the point of inflection where it switches. This was concave down and now it switches to be concave up right there. So that's another way of thinking about it, but normally you can just look and see how they divided it up. That would be 10. Next one says Gina This doctor told her the standardized score for her systolic blood pressure as compared to the blood pressure of other women her age is 1.5, which of the following is the best interpretation of the standardized score. So what does that Z-score mean? So this says Gina's systolic blood pressure is 1.5 or 150. I can't tell what that says. Well, whether it's 1.5 or 150, that is not what a standardized score is. You don't really need the formula, but let's go and write it down. It might help. It's saying, because the formula for Z-score is your observation, her actual blood pressure, minus the mean for every woman her age's blood pressure, divided by the standard deviation of the blood pressure for women her age. So, and they said her Z-score is 1.5. So what is that 1.5? It's measuring how many standard deviations away Gina is from the mean. So let's see what says that. Gina's blood pressure is 1.5 standard deviations above the average systolic blood pressure. Okay, that sounds good. Why would it be above? Because the Z-score is positive. She was beneath the mean. If you think about the formula, it would be negative. So that one looks good. Let's keep reading. Her blood pressure is 1.5 above the average blood pressure. It's not just 1.5 above, it's how many standard deviations above. So that one's wrong because it's missing that. Next one, it says she's 1.5 times the average. That's just not the right definition of the Z-score. And only 1.5% of women her age have higher, and that's not the right definition of Z-score either. So it is B. Next one on this page says a company wanted to determine the healthcare cost of its employees. A sample of 25 employees were interviewed and their medical expenses for the previous year were determined. Later, the company discovered that the highest medical expense in the sample was mistakenly recorded as 10 times the actual amount. However, after correcting the error, the corrected amount was still greater than or equal to any other medical expense. Which of the following sample statistics must have remained the same after the correction was made? So all that's saying is you're not multiplying everything by 10, just that largest set of your data was 10 times larger. But then when they fixed it, it was still the maximum of the data. So it's just saying, like, if this is your data, this largest one was 10 times greater than it actually was, what would stay the same regardless of how large this maximum is? Would the mean stay the same? Let's say that first this was 100, but it was actually meant to be 10. The mean would change, definitely. The median would not change, right? Because you're still going to cross that off first to get to the middle. Because the median is the thing that's resistant to outliers. The mode, it could change if that ended up being the same as this is 10. So we're not for sure, that one must have stayed the same, but it could have stayed the same. Range would definitely change if you do max minus min, and variance is tied to standard deviation, right? Standard deviation squared, and that would also change because you used all your data to calculate that. So the median is the one that's most resistant to outliers. Okay, on the back, you have a stem and leaf plot. It says its back-to-back stem and leaf plot below gives the percentage of students who dropped out of high school for each of the 49 high schools in a large metropolitan school district. So for the school year 1989 to 1990, for 49 different high schools, this is the percentage that dropped out. So this is 9%, 9%. This would be 14% because you use this as the tens place. The highest would have been 37% dropout rate for one of the high schools. And then this is the same information, but for 1992 to 1993. So it says, which of the following statements is not justified? So A says the dropout rate decreased in each of the 49 high schools between this year and that year. So between this year and this year, that's saying each of the 49 high schools decreased. Well, we don't know what number goes with what high school, right? You can look at this data and maybe say it decreased overall, but one high school, what if this 11% changed to this 23%, but all the other ones decreased. So you just don't know. You can't compare because we don't know which number here goes with which number here. So we're not for sure about that. So that should be our right answer, but we can go through and read the others if you thought there was another right answer. So this B says, for the high school year shown, most students in the 49 high schools did not drop out. which makes sense because most would be like greater than 50%, and we can see the highest that it gets to is 37%. So most did not drop out. So that's true. In general, dropout rates decreased from the 1989-1990 school year to the 1992-1993 school year. So you could look at this and see that it did seem to have decreased. It got more skewed. What? Now I gotta draw it. Skewed right. So that one's true. The next one says the median dropout rate of the 49 high schools decreased from the first school year to the second school year. So you have to find the median. So I'm not going to actually do this, but I'll show you how I would do it. So for the 1989-1990 school year, I would just start crossing off from least to greatest, right? So my smallest is 7%. My greatest is 37. Another way you could do it, if you don't like crossing off, is, there's 49 total high schools, so you divide that by 2. And what is that? That'd be like 24, right? 24.5. So you cross off, you can start at the smallest or the largest and cross off 24, and then that middle one would be your median. And you could do that here and do that here, and you can see that it's going to be smaller for that 1992-1993 year. But because I'm so sure about this, and I'm not going to do it, but you could test that out if you want to, but it should be true. Let me see if I have it so you can just check. I don't. And then the spread between the schools with the lowest dropout rates and those with the highest dropout rates did not change much between this first year and that second year. So it's just saying the spread, the range, didn't change much, because the range here, the highest was 37 minus the lowest was 7. So that range was 30. Over here, the highest was 35 minus the lowest was 4, which was 31, so you can see it didn't change much. So the correct answer is A, because we don't have information about each of the high schools. Okay, next one says, at a college, the scores of the chemistry final exam are approximately normal, with a mean of 75 and a standard deviation of 12. I'm going to go and write this down. So normal for the chemistry exam, the mean of 75 and a standard deviation of 12. And then for a calculus exam, they are also normal. So for calculus, and it had a mean of 80, and a standard deviation of 8. The student scored 81 on the chemistry and an 84 on the calculus. So our observation for chemistry was 81, our observation for calculus was 84. Relative to the students in each class, and what subject did the student do better? Right, so you can't just compare 84 to 81 because it's relative to its distribution. So to compare two different values in different distributions, that's why you standardize. That's what helps you compare. So we're going to find the z-score for each of these and just see. So the z-score for this one would be your observation minus the mean divided by the standard deviation. And this one would be observation minus the mean divided by the standard deviation. And if you type those both into your calculator, we can compare them, which I think they're both 1/2 if I remember correctly. But let's make sure. 81 minus 75 divided by 12 is 1/2, and 84, why did I write 84 minus 84? 84 minus 80, the mean, divided by 8. Oops, I did that wrong with my calculator. It'd be 4 divided by 8, which is also 1/2. So our z-scores are both 0.5, right? So because the z-scores equal 0.5 equal 0.5, if they're the same, then they did relatively the same compared to their class. So we would say did equally well in each course. Okay, next one says, for which of the following distributions is the mean greater than the median? So this is where you have to know what a skewness does to the mean and the median. We know the mean will be pulled out more in the tail. So on this one, here's your median, and here's your mean. because it's going to be pulled more into the tail. So you got to think this is a number line. So if whatever's to the right is greater, so then in this distribution, the mean would be greater than the median. So that should be our answer. We can kind of look at the others here. Because it's symmetrical, the mean and the median are going to be the same. Because it's uniform, just a rectangle, the mean and the median are going to be the same. Again, it's symmetrical, so the mean and the median are the same. And this one, it is skewed left, so the mean is going to be pulled more into the tail than the median, which means it's less than, because it's on the left side of the median. So the answer is A. Next one says, suppose that the distribution of the set of scores have a mean of 47 and standard deviation of 14. If 4 is added to each score, what will the mean and standard deviation of the distribution of new scores? So it's saying if you are transforming your data and you're adding a constant to all your data, what does that do? If you add a constant, what does it change? It only changes the mean, right? Spread is not changed by adding a constant because it would just shift everything. So the spread wouldn't change, but the mean would. So you need to add that 4 to the mean. So it was originally 47, now we add the 4, so it's 51, and then the standard deviation would stay the same. It'd still be 14 because you don't add. Now if you were multiplying, you would do it to both. So the answer is A. Okay, next one says the lengths of individual shellfish in a population of 10,000 shellfish are approximately normal, with a mean of 10 and a standard deviation of 0.2. Which of the following is the shortest interval that contains approximately 4,000 shellfish? So this one's tricky. You really have to think about the shortest interval, so you got to use your answer choices that contain 4,000 shellfish. So how do you know what interval would, if you're thinking about a normal distribution, how do you know what would contain 4,000 shellfish? Well, you got to think what proportion is that out of your 10,000. Because you can't really do a shaded amount as an area. So like, because we know our mean is 10, if we were going to shade this from 0 to 9.949, 0 would be way out here to 9 point whatever. 9, if you were going to shade that interval, that would be the proportion of shellfish. So we want to know what proportion is 4,000 out of 10,000 total shellfish. So if you do that math, 4 out of 10, so you're looking for which interval is going to give you an area close, approximately a 0.4, but it has to be the shortest interval. If you miss that, you'd get this question wrong. So how are we going to do that? Because you're going to do normal CDF for all of these intervals and see which one gives you 0.4 or really close to 0.4, and then pick the shortest. So if you just started at A, here I'll say you're going to do, I'll write down my work, normal CDF, and you're going to pick your lower bound, upper bound, which you're going to use your answer choices, use your mean of 10 and your standard deviation of 0.2. So I'll show you the fastest way you would test all these is do the first one. So you go to menu, statistics, distributions, normal CDF, which is 2, and for my first interval I would pick 0, my lower bound 9.949, my mean is 10, and my standard deviation is 0.2, and that is 0.3993, which is really close to area 0.4, correct? So that could be an answer, but is it the shortest interval? Because that's kind of a large interval if you find that range. That has a range of 9.949. So we want to keep going and test all of them. That's why this one's tricky, because if you're on your test and you got that and you just circled that, you would get it wrong. So we got to test all of them. The fastest way is you just don't redo it. Just scroll up, push up until you highlight normal CDF, push enter, and then just change your boundaries. So now we want a lower bound of 9.744. and an upper bound of 10. And that is also 0.3997. So that's also really close to 0.4. I'll say these are both approximately 0.4. And that is a shorter interval, correct? So that one, we know that this one's wrong because it's not the shortest. Next one would be 9.744, still your lower bound, but then you go to 10.256, which that's not close to 0.4, so that one's wrong. Next one would be 9.895 to 10.105, and that also has an area of approximately 0.4. So that's an option 2. You just got to find which one's shorter. So if you're not sure looking at those, we'd have to find the range for each. Let's go ahead and do the last one real quick just to make sure. 9.928 to 10.08. And that's not approximately 0.4, so that can't be it. So I would be deciding between these two, and if you're not sure, you would compare the ranges to pick the shortest interval. So 10 minus 9.744, that has a range equal to 0.256. Don't use R as an abbreviation for range. I'm just doing it on this problem. I'm running out of room. And this range would be 10.105 minus 9.895, and that's a range of 0.21, which is smaller. So this is the shortest interval that contains approximately 4,000 shellfish. Okay, last one. It says the figure above shows a cumulative relative frequency. So that a cumulative relative frequency is like percentiles. It gives the percentage below that data set. For 40 scores on a test, so that's your sample size, given an AP Statistics class, which of the following conclusions can be made? So the first one says there is greater variability in the lower 20 test scores than the higher 20. So you got to think about, that's talking about the first, 50% and 50% out of your 40. So the first 20 test scores, because this is not frequency, this is not a count, it's cumulative percent relative frequency. So 20 test scores would be 50% of your data. So you go to 50%, and that would be right there. So 50%, the median is somewhere between 80 and 85. Is between 80 to 85. We're not quite sure. So what does that mean? The first 20 test scores vary. Like even if you use 80, to the lowest test score was about, that looks like 35 maybe, because none go here. But 80, even if you just say 30, 80 minus 30, the range would be 50. For the first 20, the first 50%, and the last 20, the highest 50%, range from, even if you still use 80 or 85, the max range would be to 120, right? Could be even smaller, it could be 15, but even if it's 20, there is definitely more variability, a higher range in the first 20 test scores than the higher 20 test scores. So that should be the right answer, but we can look through the other ones. So the next one says the median test score is less than 50. So we just said the median is between 80 and 85 because that's where the 50% percentile is. So that one's not true. Right, the median is the 50th percentile, if you weren't aware of that. Next one, 60% of the students have test scores above 80. So this one you would be close. This one is the closest to picking. But this one is just, it's so clear that there's greater variability. This one's a little iffy. So if 60% make above 80, then that would mean, because percentiles is easier to look at below, the percentage below, so that would mean 40% make below 80, which if you look, that would mean, because below 80 are these, that could be 40%, right? Make below 80, because below 80 would be whatever this percentile is. And that looks like it could be 40, but it could also not. It could be 41, and we're just not quite sure about that one. So if it was the best answer, you would pick it, but so far that's the best answer because that is very clear. This one's not quite as clear. So even though that's an option, A is a better choice. Remember, in statistics, you're picking the best choice. D is if the passing score is 70, most students did not pass. Well, you can see 70 is right here. And the majority is greater than 70. So the majority did pass. You only have this little bit that didn't pass. About, I don't know, what is that? 25% didn't pass. So that one's not true. The horizontal nature of the graph of test scores of 60 and below indicates